Let's look at how we apply this in the networking sense. If we look at my demonstration network diagram, right now I put my inside PC and my inside web server on the same network. And what this means is that they have direct IP access to one another, and there's no restrictions in their communication. This can be dangerous because if I am out on the internet PC and I'm an attacker and I have NAT set up and an access rule set up to access my inside web server, which I do. We did that in our previous video, right? We set up NAT and made sure the access rule is in place so the internet PC can access my inside web server. Now, if that internet PC somehow finds a way to attack that inside web server on port 80 and compromise and gain access and control of that inside web server, now that person, that attacker out on the internet PC, now has direct access to my inside PC. That's exactly what I don't want to happen. That's defeating the point of my firewall. So what I want to do is create a new interface and move my web server to a completely different interface on my firewall. To do this, my new interface is going to have a new IP address, 192.168.42.1 in my case here. So we'll have to move my inside web server to a whole new IP space as well. So I'll change the IP address now to 192.168.42.80. Now, when we talk about trusted and untrusted zones here, when we talked about security levels in the first module, we found out that the trusted interface on the Cisco firewall, we give a security level of 100, the most trusted interface. Our outside interface, which is our untrusted interface, gets a security level of 0. And when we talked about this in the first module, we noticed that traffic can flow from trusted networks to untrusted and back again, but it cannot flow from untrusted into trusted networks unless there is an explicit rule allowing it. So the DMZ, what I do is I set the security level of a DMZ to be someplace in between trusted and untrusted. And that way we create this perspective and traffic flow design that we're looking for. So what this means is that my inside PC can browse to my inside web server without an issue because my traffic is flowing from a trusted interface to an untrusted interface, no problem. But what can't happen is my inside web server cannot access my inside PC unless I create an explicit rule on the DMZ to access resources on my inside PC. So because that traffic is flowing from a low security level to a high security level, that means that traffic is going to be blocked by default. However, my inside web server can talk out to the internet and back again if it needs to, because that's flowing from high security level to low security level. So what we would do here now is we would just modify my inside web server configuration on the firewall to allow traffic in from the outside interface to allow it to reach the web server on port 80, and then the web server can reply to that traffic. Now, if the user on that internet PC compromises my inside web server on port 80 and takes control of it, now that user only has access to resources on that specific DMZ. That user will not be able to browse from the inside web server to the inside PC at all. So what will happen is my attacker will have compromised my inside web server, which is a problem, but my attacker will not be able to get access to other resources within my network. So that's the concept of our DMZ. We create an interface on our firewall, and we give it very specific rules about what traffic is allowed into that area as well as allowed out of that area.